Welcome everyone to this session where we are going to figure out to Bicep or to Terraform. And pretty much we are going to look at this from the perspective of creating resources in Azure. And for me, that is one of the first questions that always comes up after deciding that, yes, we will go ahead and use infrastructure as code. The two options that come up are Bicep and Terraform. And often the reasoning behind why people go one way or the other is, well, I like Bicep or I like Terraform. And even though that is okay reasoning, I guess, but we could have more a data-driven decision where we actually have knowledge of how does Bicep and Terraform actually work, where is one thing easier and where is one thing harder. So today we will try to kind of get through the main points of where can we see differences between these two tools. And of course, when we talk about infrastructure as code for Azure, the first thing that might come to mind is the beautiful ARM templates. Has anyone tried these? Did you like it? I have sometimes heard that people have liked it, so I've had that answer as well. But I have to say, for me, it was kind of clunky. You get all excited, yay, I'm gonna automate my infrastructure creation, and you're like ready to roll up your sleeves and you're ready to get going, and then you end up banging your head against the wall for a day, figuring out the syntax, for example. But the idea is good. The idea is actually really good. The idea is that we can have a configuration in place that defines our resources, and then just by handing that configuration to Azure, it will spin up everything that we need. All the different resources and how they relate to each other. So we have like a way in which we can always systematically define everything. Luckily nowadays we have better options. A few years ago, we didn't have that many options, actually. So ARM templates were the way to go. But luckily, we have easier options now. So what we're going to be talking about today is Terraform and then Bicep, as the title may have given away for you. And luckily, that will make our life a whole lot easier than ARM templates. So if you don't know who I am, I'm Heini Ilmarinen, and I work as the Azure lead at Polar Squad and as a DevOps consultant. I have worked with both Bicep and Terraform in Azure environments, and a lot of the emphasis that we have is figuring out how do we bring our really architecture to life using infrastructure as code in a systematic way so that there is no like, oops, I clicked the wrong button scenarios. I'm a data platform MVP and an MCT, so I also run some trainings. I am a third of the Knee Deep in Tech podcast, where we talk about tech and all the different things in that make possible for us to do all these cool things. My favorite topic revolves around architecture, and for me, infrastructure as code is what enables us to bring architecture to life. So it is kind of choosing the way in which we implement architecture. And my math background is in mathematics, so I was aimed to become a math teacher and then decided to hop another way. So if anyone wants to talk math at some point, we won't during this session, but feel free to come and chat with me. And as you might have already picked up, I'm a bit of a serial doodler. That's how I myself figure out the world, and it just makes sense to have it in my slides as well. So to get to the bottom of today's topic, we're going to start with an introduction to infrastructure as code. And really that will help us understand the similarities between Bicep and Terraform. Where do they have, what is the common ground for them both? Then we will look at the differences. So we will look at certain topics with both Bicep and Terraform and figure out how do we do certain things differently. And then lastly, we will look at, well, how do you then actually choose the tool that you are going to use in your environment, using the information from the previous section. So let's get straight to an intro to infrastructure as code. So if we think about infrastructure as code, in its most basic form, it is a way in which we have some kind of configuration language that we use to define our resources. And in its most simplistic way, it could look so that we just define this resource and we give it some parameters. We give some configuration values for it. And syntaxes, there are many, but with this configuration, we then are able to get up those resources that was the attempt with ARM templates as well, that you would have a simple syntax that you can use to get your resources up. So really, we can do both creation and management activities with this. So we just always change the configuration, and once we pass it on to the platform again, we get the changes that we have defined. And as said, there are many options. With Azure, the history is ARM templates, luckily not then here and now. Then on top of ARM, that is where Bicep has been built upon. And then we have also third-party options. So what we're going to be talking about today is Terraform, but there is also a tool called Pulumi, which is used maybe a little bit more on the application platform side of things, because there you have programming languages that you can use to define the configurations. But what is common to all of these different tools, and especially with Bicep and Terraform, is that these are declarative. So what that means is that we just define the end state of our infrastructure. We say we want our resources to have this particular configuration. We don't actually tell the platform in which order it should do the configurations or how it should get to the end result. We just say, hey, this is the end result that we want in our environment. And then on the other hand, these are also idempotent. And what that means is that we can run the configuration against any state of the environment. So it could be that we have no resources, we have all the resources, we have 2 resources or something like that. But always when we run that configuration, we end up with the same end result. So that is what makes it idempotent. And if we think about this, this makes it quite nice to use infrastructure as code. We just need to define the end result. We don't have to care about what is the start situation of our environment. But if we then have the configuration, we can get to the same end result with these. If we think about infrastructure as code, there are actually quite many benefits, and these are just the ones that are the most important to me from the projects that I've done. The first thing is that, well, actually we get quite a bit of documentation when we use infrastructure as code. We don't have to go pulling some configuration values out of the Azure portal and store them somewhere to know how our resources are configured. We can go straight to our infrastructure as code configuration and check, how did we configure this particular resource? You will still need some kind of high-level overview architectures. With infrastructure as code, it's not so easy to see how the resources link together. So probably for that area, you still want to have some high-level pictures in place and documentation in place. Secondly, you have the repeatability. So that is really beneficial. So on the other hand, of course, if you're making multiple customer environments in for example, a consulting role, there you could have templates ready to go whenever you need and just have a basic setup in place. But even if you don't have that kind of scenario, but you, for example, need dev and test environments that are identical to your production environment, or if, for example, something goes wrong in your production environment, you can create a replica of that environment and figure out what is going wrong. So you really get that repeatability. You don't have to then, oftentimes when we need repeatability, it is the situation where things have already gone wrong. And when you then start to hectically click around and try to get the resources up in the same manner, it often doesn't work. So even though sometimes infrastructure as code takes a little more work in the beginning, you then have this kind of sense of certainty in the situations where things do go wrong. And then you can rely on the infrastructure as code to work. And thirdly is the fact that we can actually version control our infrastructure. And that is really important. So if we make an infrastructure change, we are able to track what kind of changes have we made. And if things go wrong after a certain change, we are then able to go back into the previous state. And just like any other notebooks, file-based things that we might want to track, we can track the infrastructure as code configuration files in the same way. So really, those are huge benefits that we can have for our environment from using infrastructure as code, and it doesn't depend whether the tool is Bicep or Terraform. This is always something that we can then leverage. If we talk about this a little bit from the Azure perspective, what happens actually behind the scenes? So you might have heard of ARM or Azure Resource Manager. That is kind of the engine in Azure that takes care of how all the different resources get created. But behind the scenes, we actually have something called resource providers. And these we have for each different type of resource that is in Azure. So there is one for storage, there is one for SQL, data factory, networking, and so forth. And each of these resource providers define what kind of resources can you create, as well as what kind of configuration options do you have for them. And each of these have an API that can be called. And when you go ahead and actually create a resource in some form or manner, it doesn't matter whether it's the portal or Azure CLI or something like that, it is the Azure Resource Manager that we kind of send our request to, and then that forwards those requests to the resource providers themselves. To help some tooling communicate with the Azure Resource Manager API, we have SDKs, so software development kits, and those kind of apps give you like a middle layer that then allows you to, for example, interact with Go with the actual API of the ARM layer itself. So if we think about this from the perspective of ARM templates, we are actually directly communicating with Azure APIs themselves and not through the SDKs. But because of this structure that is in place, that is actually what enables us to use those beautiful ARM templates and for us to find the resource configurations when we go to a resource group and say export template. It's this particular structure that enables us to do that. So each of those resource configurations is stored with their API, and then you can fetch it and see what is the current state. All right, so we now know a little bit about the basic premises of infrastructure as code, as well as how infrastructure as code functions with Azure specifically. So let's start to get then more in depth into today's topic of really figuring out what are the benefits for both Bicep and Terraform, and how, on the other hand, they also differ from each other, because there are differences between these two. So if we look at the high-level comparison to start with, so we have Bicep and Terraform here. I have Bicep-ARM because actually behind the scenes, currently, most of the time, Bicep compiles into an ARM template that then gets passed to Azure itself. So it's just a language that makes it easier for us to write ARM templates, really. So if we start first off, Bicep and ARM are, of course, Azure native. So they function directly with Azure, and they don't have to track the resource state in any way. They can always check against your resource. Has it changed, or should it, does the configuration now change the resource in some way? Whereas with Terraform, we actually have a separate tracking mechanism for the state of the resource. So what kind of configuration does it have in place? Because Terraform does not communicate directly with the Azure APIs themselves. So we need to have this way of figuring out what kind of configurations does our resources currently have. And on the other hand, that helps us also figure out if our resources have been changed manually, for example, because sometimes it happens that somebody goes in and clicks around and oops, our configuration and resource are not in line anymore. Secondly, if we look at Terraform side, this is kind of the implications of Bicep being ARM native. So for Terraform, we actually have many providers. So the provider is what makes Terraform be able to communicate with some kind of compute platform. So of course, today we're mainly going to be talking about Azure, but there is also providers for other kinds of resources. So for example, you could use Terraform to configure resources in AWS, or you can also use a Databricks provider to actually configure your resources within Azure Databricks. So the compute clusters and things like that. Whereas, of course, if we compare to Bicep, there is not this concept of many providers. There is on the Bicep side, there has started to be a little bit of an evolution this way. There is this kind of a Kubernetes extension that you can use that allows you to then first deploy the Azure Kubernetes resources and then work on the Kubernetes level there. So it's interesting to see, will actually Bicep move more towards this model of also being able to work with other platforms as well? We'll see. Not yet quite sure looking at it at this moment. With Terraform, that does talk, as I said, it doesn't talk directly with the Azure APIs, but it actually functions with the Go SDK. So this has the implication that the Go SDK doesn't get updated until something becomes generally available. So if there's any preview features that you would like to use, we need to be a little, well, there is ways to do it, but it's not in the general way as you would use Terraform in other situations. So that does bring that little dependency on having to wait for the Go SDK to be up to date. So if you use a lot of preview features, you should probably think about how does this affect you. If we look at the language that is used for the configuration, both of these languages have their own configuration languages. So in the Bicep, we have Bicep declarative syntax language, so Bicep DSL. And then, of course, on the ARM template side, it is JSON. And on the Terraform side, we have HashiCorp configuration language. We'll take a look at what that looks like on the top level. We're not going to go today into details of how you do the configurations, but you'll kind of see at the top level, do they look any different or which looks simpler and so forth. You kind of get to make the assessment there. So if we then go back to this picture of what's happening behind the scenes based on the information that we just went through. If we work with Bicep, we of course have somebody with a laptop who starts to create Bicep files. You need to have Bicep installed on your machine. And then you can use either Azure CLI or PowerShell to do the actual deployments. So that's also what you will need. But after that, you can just go ahead and create your first Bicep file. And as said, behind the scenes, this actually gets compiled into an ARM template. And then that ARM template gets passed to Azure after that. So there's kind of this subphase that is really invisible to us, but it's good to then, it helps us understand why Bicep supports the scenarios it does, because it does this behind the scenes. If we instead look at the Terraform side of things, again, we have somebody who's creating the Terraform files on their machine. You are going to need Azure CLI, and then you need to also have Terraform installed. With Terraform, you could run the actual Terraform commands with PowerShell, but for you to authenticate with Azure, you're going to need Azure CLI. So it's kind of like, well, then it's better to just go with Azure CLI and not use both of them. So it's required for the authentication part of that. But again, you don't need any other tools like other than that. Of course, some kind of code editor helps. Visual Studio Code has really good extensions for both Terraform and Bicep and has good IntelliSense for you to help with the authoring of the files. So that's always a good idea. But with the Terraform, as we said, it doesn't go directly with the Azure APIs, but actually goes through the Go SDK. So there is that middle layer in between before we get there. And one other thing that happens with Terraform is that we also get a state file that gets created. And that was what we discussed. That is what tracks like the previous run of Terraform and what it expects the state of the resources to be at that point. So the next time that you run Terraform, it will check against that state file and see, is there a change here that I need to make? All right. With that, we're gonna start looking at this in practice. And we're gonna start by looking at this resource state because it is quite a big difference in how the tools work. And we're gonna start from there and then go a little bit into talking about the scope of the changes that you make, and then kind of how are changes handled and how can you check for changes in your files in these two different tools. So I have to duplicate. So since we only have quite a short amount of time for this session today, I've already prepared some files both in Bicep and in Terraform so that we can get started quite easily. So here I have a Bicep file that is scoped to a resource group, and I have some parameters defined. So those will be something that then I can use in my Bicep file later on. And then I have just one resource defined at this point. So I have a storage account defined. And in Bicep, it goes so that we create this resource block. Then you tell what kind of resource are you creating. And then you have a reference to which resource provider API version you want to use. So this is what this is referring to. So we are using the Microsoft storage resource provider. We are creating a storage account in there using that resource provider. And this is the API version that we are using. So we have to specify quite a bit, and this is the information we also had in ARM templates, and this could have always been a little hard to figure out. With Visual Studio Code, the IntelliSense gives you a suggestion on which version you want to use, and most of the time you do want to use the latest version for it. And then pretty much we have just these value configurations of, hey, what do I want the name to be? What do I want the storage to be? The location to be, and so forth, and the other settings that are required for a storage account. So it depends, of course, always on the resource, which kind of things do you need to have enabled here or set. And I've also actually done the is HNS enabled, so the hierarchical namespace. So that means it is a data lake in this case. So in this top part, I had defined this namebase as a parameter and given it a value. So that means now that I am referencing this here in the name, so it becomes a part of that string value there really easily. So this is what a Bicep file looks like. To create one resource, it's not very complex. We can define some parameters if we want to, and then just have the actual resource definition that we need. So let's get to deploying this. The one thing we need to note with a Bicep file is that the default scope for it is the resource group. So if we don't define anything else, it will create those resources within one resource group. Question? So, yeah. So the question was that what are the specific reasons that we've moved away from ARM and gone to Bicep now? And it is mainly because of the complexity of ARM. ARM was just like lagging behind, for example, Terraform like hugely. Once Terraform came into the picture, like ARM could not really compete with that in the simplicity. Yes.
Yeah, sorry.
Yes.
Because then you don't have to repeat it.
Yes. Yes, thank you.
Sorry about that.
Go ahead.
Yeah, but what I'm saying is that ARM templates used to be incredibly slow for us, especially deploying resources like event hubs, complex functions, and things like that. And we found out that Terraform was faster. You say that Bicep compiles into ARM, so do you have still have the same performance issues with Bicep that you had with ARM?
From experience, most of the time, yes.
Okay.
It currently does compile to ARM. We'll see what direction it will go in the future. But pretty much any restrictions you had in ARM, you still have in Bicep, most of the time. There are some exceptions, like the Kubernetes one that I said.
Thank you.
I'm not exactly sure why there is such a performance difference with certain resources in ARM and Terraform, because it doesn't really make sense. Both of them still go to the Azure management plane, and both of them have to call the actual resource provider to put up the resource. So yeah, there is probably something in how the ARM is handled that makes it a little slower. But yeah. So each Bicep file is scoped to a resource group by default. So you are just, with this, you are just managing one resource group by default. We'll get to the other options in a moment. So that means that I don't actually, in this file, I don't define the resource group that I'm creating. So I'm not creating a resource group. So that means that I actually have to create that separately. So I put my commands here ready so I don't have to type on the go. So I just use Azure CLI to create a resource group for me with this name, RG-Bicep-Haney. And then now that I have the bicep file here, I can see from this that it actually uses the resource group location as the location then for also my storage account. And then to deploy this, I have a different command that I'm gonna run, which is the AZ deployment group create, where you specify the resource group that you wanna use, and then the template file that you also want to apply. So now it's gonna actually run those changes and create the storage account for me in Azure, just based on this one configuration file that I had in place. So let's see how fast it is today or how slow it is today, but we'll leave it running while we go and look at the Terraform side. So again, I have some Terraform files already created. This has the same setup as we had on the Bicep side. With Terraform, the scope can be whatever you want. So you can choose which resources you want to manage with Terraform. You can manage management groups, you can manage subscriptions, you can manage resource groups, single resources, whatever is your choice for this. So we're gonna create a resource group, and then we are gonna create a storage account as well. It is quite similar to what we had in place on the Bicep side, a few little differences. I have separated the variable into a separate file in this case. You could do that with Bicep as well. It just makes it easier to then find if you have many, many variables, you just have them in one place. Here I've given it a default value to use. And the one additional thing that we need with Terraform is something called a provider block. And with that, we are going to define which provider are we going to be working with. It is actually able to pull the provider information automatically as well behind the scenes. But the provider does have updates frequently. So when you specify that, yes, I'm using the Azure RM provider, which is the one that we use with Azure, then you are also able to specify the version, and that doesn't happen so that my demos break because there's been an update. So it's just a good practice to have the version somehow tied, whether it's a strict kind of, it has to be this specific version, and then you update it when you need to. So with Terraform, it grabs all the files that have the .tf in the file ending. So the separation to different files is just for you to make it easier to figure out where is each of your configurations. So it's nothing more than that. So Terraform actually pulls all these 3 files together and then does everything that is specified in all of these files. And with Terraform, we first are going to do an initialization. And what that does is it actually fetches the correct Azure RM provider version, and if you had any other provider specified as well. And it also specifies a backend for it, which means where does it store the state file. Right now, I'm allowing it to do just the default thing, which is to store the state file locally. In production, you want to have that somewhere remotely. It could be hosted on an Azure storage account, but somewhere where all the users that are working with Terraform can actually reach that state file, so that there is one state file tracking the environment status. So after it has been initialized, I did not actually show this yet on the Bicep side, but with Terraform, I can easily check what kind of changes is it going to make. So for that, I can use Terraform plan as the command. Then it's just going to check, well, what are the kind of changes that I would need to make at this point? Normally, it does not take too long. Let's hope the Wi-Fi is okay here. So it gives me this really detailed list of both the resources it's gonna create. Let me scroll a little bit further. So we have the resource group here. That is quite simple, just has a few properties, whereas a storage account, with Terraform, you kind of get to see behind the scenes what are all the settings that you have available to you. And even though I specified just a few, it will show me quite a bit of the other information here as well. So there's a little bit of a learning curve to be able to like pinpoint the relevant information in the changes and then get going from there. And then to actually make the changes, I'm just going to run Terraform apply, and that is then going to still actually run the plan phase and then check with me, do I actually want to make these changes or not. So if we compare the Bicep and the Terraform, both of the syntaxes are quite simple. I've checked the changes already, so I'm just going to type yes. But with Terraform, you have maybe a little more fluff around. If you look at it, the Bicep was a little more condensed than the Terraform version. Mainly with the Terraform, we have to specify the provider and the version that we want to use for that, whereas with Bicep, there's not a concept of provider, so we don't have to specify anything. We just use Bicep. Yeah. Just a second.
It'll make it much easier.
With Terraform, is this always an incremental deployment against the state file, or?
So it will. Do I have to repeat the question? Is that what it's saying? I don't think I need to repeat.
Sure? Yeah. Okay.
Because we have the mic. All right. So with Terraform, it will check against the state file, but to some extent, it will also notice if somebody has gone poking manually.
Oh, okay.
So then it will also tell you that, hey, your resource has changed since the last time that you ran Terraform. And this is mainly if you like adjust a resource that Terraform is already managing. If you add a completely new resource that hasn't been in Terraform yet, it will not be aware of that from the get-go. You have to do steps to actually make that happen.
Thank you.
All right, so our Terraform resources are up, at least according to my command line here. Also, it looks like the Bicep configuration worked as expected. So if I go here into my resource group view, I hope I'm in the right subscription, yes. So I have my Bicep resource group that has one storage account, and then I also here have a resource group that has my Terraform created storage account. So they have appeared here by magic, almost. So of course, this was quite a simple resource configuration, but in principle, it works the same way, whether you have 10 resources or one resource. The basic principle is the same. So if we look at the Terraform side, we have this concept of state file. So you can find it now here locally on my machine, since I did not specify a remote location for it. So then this is what actually handles how are the resources right now. So for example, it then lists the different attributes of the resources that we have created. We can find the Azure storage account configuration here, etc. This is something that you shouldn't go and poke manually. So it is something that should always be just managed by running the Terraform commands. There is quite a bit of Terraform commands that you can use if there is any like glitches in your state file, but today we won't go into those. One important thing that we will note with a Terraform state file is that, can you see this? Primary access key is in plain text on my Terraform state file. That is not very good from a security perspective. So you should always treat your Terraform state files like they are secrets. So if you, for example, store it in Azure storage, make sure you have some kind of firewall rules in place, make sure there is access control in place so that only the users who need to actually read it can read it. So that's very, very important with Terraform. And in my opinion, one of the biggest weak points in Terraform, the security aspect of storing keys in plain text. All right. For Bicep, we don't have the similar kind of concept. There's no state file that has appeared or anything like that. Bicep will then compare this against the resource group that is in Azure when you make the changes. I showed with the Terraform while we were doing the changes that we can do kind of this plan step, and we have a similar command for the Bicep. right now, it's this AZ deployment group, what if? So that can show then us what kind of changes it puts into place. My experience with this is that it works some of the time. It is not 100% bulletproof. Sometimes it's not able to show you all the changes that should be made. I'm not sure, but they are still working on it to make it work better, and it has gotten better over time. So right now, we have the same configuration as we had before, so it's gonna say that there's no changes. But if I here, for example, take out this comment and let it have the data factory resource there as well, and run that command just a second time, it should then be able to tell us that, hey, there is this data factory resource that has appeared, and now this is what we need to add. It will do some checks against Azure, so it will be able to catch things like if your naming is not according to the requirements and things like that, but occasionally it does miss some things from the kind of validity checks. But here it's a different kind of view, but similar things as we had on the Terraform side. It shows what kind of resource are we creating, and then the different configurations that are associated with it. A data factory is quite simple in that sense that most of the things are within data factory that we then do. So it looks quite simple on the changes to come on this side. But so if we kind of recap between Terraform and Bicep, in Terraform we have this concept of a state file that we have to figure out and handle. In Bicep we don't have that. On the scope side, Terraform, you can choose the scope that you want to use. In Bicep, the default is a resource group, but you can actually also change it to the subscription or management group scope. And then changes you can kind of view beforehand in both tools. I have to say the Terraform side is more reliable on that side. Bicep is getting there, but still has a little bit of hiccups at times. Just in regards to the scope, I don't think we have enough time today to go through a full-on sample, but I have this second file here that has been scoped to a subscription level. So then that means that that specific file will define the resources within that subscription. And in other senses, the configuration is quite the same. So now, since we are at the subscription level, then we are also able to define what kind of resource groups do you want to define in that subscription. So in here we have then the resource group creation. And then I also had a secure parameter here for giving the admin password for a SQL. And then for the content in the resource group, we need to use a module if we use this higher scope. So then this is what defines the resources within a resource group. So then we kind of have this structure where we have one file folder for the subscription, and then we have another file that we point to that defines the contents of the resource group. So if we have multiple resource groups, then we would have multiple of these modules in place. And as you can see here where I call that module, I have the scope of resource group, and it points to this file in the modules folder called data.bicep, and this, on the other hand, looks just like the single file that we looked at in the beginning. So that's kind of the idea if you want to go to a higher scope, and it of course then depends on your project. If you have a full subscription that you're working in, or maybe you have just a single resource group that you have access to, then you would just use the resource group scope. All right. Then we are going to get to the next topic, which is what do we do with resources that have maybe been created manually? That is kind of an important thing, because it might be that either our environment has been created beforehand and there has not been infrastructure as code in place previously, or somebody goes in and pokes things in the portal, which does unfortunately happen unless you have restrictions in place so that is not possible. So let's go back to our portal here and into our Bicep resource group, and let's just Data Factory is a good example. So I did only the what if run, so I didn't actually make the changes go through. So it should be possible now for us to create here, and the Bicep doesn't yet know of it because we didn't actually apply the changes there. So let's just make this West Europe, I think, was our location. And at this point, we don't really care about what the configuration is like. So I can just stick with the defaults that are in place. And while we wait for that, let's do quickly the same thing here as well. And luckily, Data Factory does not take long to deploy. That's why I chose it, so that we don't have to wait for it very long. I think here I had Switzerland North, of course. Very logical. Hope I got them the right way around. So now we have manually created. What? I only have 10 minutes.
Yes.
I'm so confused at times today. So now we have manually created resources for both our Bicep and Terraform environment. So let's go back to our Bicep, and we're gonna close the one that was at the subscription level and instead go back to this one that is at the, resource group level. So since we just created a Data Factory, I don't want to use this one that is in my configuration yet, so I'll comment that out. And in Bicep, there's actually a really nice way to import a resource that you have created manually. What you need to do is go to the portal, go to the resource that you want to import, and find the properties, and then copy-paste the resource ID. And then in Visual Studio Code, this is now related to Visual Studio Code as well, and wrong command. No. There we go. So we want to use, there's this command that we can use, which is insert resource, and then you just need to put in the resource ID of the resource that you want to import. And now we can see that there is this added resource here for Data Factory. It's not 100% bulletproof. Sometimes there are resources that kind of the configuration isn't 100% correct, and you might want to take out some of the resources that or the configurations that you don't need to make it a little more simple. And for example, I would want to reference this location parameter that I already have in place. But other than that, I get all the configuration of that resource into my Bicep file quite easily. Didn't take many minutes at all. And now that means that I am ready to go again. And now I haven't, I hope I saved that. I haven't told Bicep in any way that, hey, there's a new resource, or I haven't told it that I have added the resource in here. I haven't linked those together in any way. But now, since it is checking directly against Azure, it can tell that, hey, there's this new resource, and it is able to say that no changes to two resources. So very simple. So with Terraform, you can there's kind of two different ways in which we can go about it. So either we can go ahead and put in a resource block for the Data Factory resource and then do an import. But there is also a tool, command line tool called Terify. AZTFI is the command, which you can use similarly kind of as this one. You just put that command and then give it the resource ID, and it will import it in the same way into your file. But because we don't have much time, I have to skip the demo for that one. But if you search for AZTFI, you will find how to go about that. Then with that, let's get back to our slides here. Since I have a little too many. Oh, now it didn't have to apparently start the presentation again. There we go. All right, so we went through resource, state, we went through the scope, of the configuration, and we went through the changes, how you kind of can evaluate beforehand how you make the changes. And then we briefly went through how do you handle existing resources. And then what I want to mention still is how do we handle preview features. And let's get back to that in a moment. So just to recap, for the resource state, that is not something we have to consider on the Bicep side, but we do have to have a state file in the Terraform side. For the scope, the default in Bicep is the resource group, whereas for Terraform, you get to decide what your scope is for the resources. For evaluating the changes, we have what if on the Bicep side, and then we have a plan that we can do on the Terraform side. On the existing resources portion, we are able to do the import in Visual Studio Code, or then on the Terraform side, we are able to use this aztfi command to do that. And then for preview features, since Bicep is Azure native, that means that they are available right from the get-go, so you don't have to do anything. For preview features on the Terraform side, you have something called AZ API provider, and it is a different provider in Terraform that you have to specify separately, but you are then able to configure any preview resources in your subscription, for example, as well. So, but the configuration looks very similar to what we have in Terraform regularly. You will have to take a little bit of the content from the Bicep side into it. I'll show that in the very end if we have a little time. All right, so what have we been going through here is we went through the intro to infrastructure as code, then we looked at the differences. So the question that stands at this point is, well, how do you choose the correct tool for your environment? So the benefits of Bicep is that it is Azure native. That is like a big thing if we're working on the Azure scene. And then the other thing that is really easy is the fact that there is no state file. That just makes it a little easier. It does sometimes also make the resource management a little harder as well, but it also makes it easier in the sense that we don't have to figure out this state file thing. For Terraform, on the other hand, the biggest benefit is that we have support for many different providers. So for example, if you create Databricks in Azure, you are then able to use the Databricks provider in Terraform to also configure all the resources within Databricks itself. So you don't have to leave those out of the scope of your infrastructure as code. On the other hand, also Terraform has been around for quite a while, so it's really steady already, and also it has frequent updates to the Azure provider. So a definite plus. So how do you then make the decision of which one do you use? Well, it comes down to how do you use Azure. So if you use just Azure resources, you can use Bicep. You don't necessarily have a reason to use Terraform. Bicep does still have slight drawbacks, so it's good to be aware of that, and the documentation isn't quite as extensive as on the Terraform side. So just be aware that sometimes you might need to dig a little longer to figure out how to do something. On the other hand, if you do need to configure any resources that are kind of outside of Azure, even if it's Databricks resources on Databricks in Azure, then you need to consider Terraform in your scenarios. But in the end, now you also have a little bit of a sense what they look like. They are similar tools, so you can figure out what fits the best in your environment. The main thing, whichever tool you choose, is stick to infrastructure as code. If you start it, do not tweak the resources manually. So put also restrictions in place that people cannot do it by accident. Secondly, kind of decide how far do you go with infrastructure as code. So for example, do you also want to deploy the Databricks specific resources with infrastructure as code? The same applies to Synapse and Data Factory and things like that, where you have resources in those services. So figure out how far you want to go with the specific tool that you choose. And lastly, once you do start to use infrastructure as code, the most benefit you get is when you also start automating and bring that to life. So thank you for joining. Please leave me some feedback on this session as well so I can improve on it. And if you have any questions, feel free to reach out to me on my socials. You can find me there with my own name. Thank you so much.